Today I'm going to talk to you about how a free radical substitution reaction occurs. A free radical substitution reaction occurs between an alkane and a halogen and it forms a haloalkane and a hydrogen halide as a byproduct. Now the first thing is an example. So methane, CH4, reacting with a halogen, let's say chlorine, making chloromethane plus hydrogen chloride as a byproduct. Now the first part of the process is the initiation. Now this is when the chlorine molecule breaks into two separate chlorine free radicals, and that's where the UV light shines onto the bond. So an essential condition is UV light breaks the bond and forms two chlorine free radicals. So in effect what happens is this: the chlorine molecule breaks into the two atoms, and we show that with those arrows. Now because this free radical is very reactive, that leads us on to the next part of the process, which is called propagation. And this is the first propagation. And so what we have is, this is where the methane gets involved. The methane, CH4, reacts with the chlorine free radical, and the chlorine free radical removes one of the hydrogens. So we make methyl free radical. That denotes the electron is next to the carbon, and we get HCl as a byproduct. To show you what happens with displayed formulae. So that's methane. There's a chlorine free radical. Let's show you the electrons there. And so this chlorine removes, bend around the corner there, removes that hydrogen and that electron there, and so you'll see that electron, where I'm pointing now red, is this electron there, and so you get so you get your methyl group and your HCl. So that's how that propagation reaction occurs. Now propagation 2. Now this is where your methyl free radical formed here is very reactive itself with that unpaired electron, and it reacts with a brand new chlorine molecule, so not this one but a new one, and it forms chloromethane and a chlorine free radical. And this chlorine free radical is free to react again, and hence you get a chain reaction until, of course, all of the chemicals react and finish reacting. So then you get you can combine propagation 1 and propagation 2 to actually get this overall equation. So with my blue pen, if I just cross out those chemicals which appear on both sides of the equation and then combine together, so we get CH4 plus Cl2 there goes to CH3Cl plus HCl. So combine propagation 1 and propagation 2 and you'll get the overall equation, which is the same as written there. Now the final thing that happens is when the reagents are finished, or when you switch off the UV light, you'll get termination. So the last stage of the process is termination. This is when the free radicals which are left over when all the chemicals are running out react together. Of course they can react together anyway. So the first thing is, let's just list those free radicals in the container. So they will be chlorine free radicals and methyl free radicals. So the first thing that can happen is, let's say we've got millions of these, billions of these free radicals in there. So let's start off with 2 methyl free radicals reacting together. So we'll form ethane. Let's say we get a chlorine free radical reacting with another chlorine free radical. So we'll get chlorine, and then finally we could get a methyl reacting with a chlorine free radical, forming chloromethane. So that's termination, that's the last stage. So there's three stages in the free radical substitution reaction. There's the initiation, propagation and termination, and hopefully I've shown you here how the whole process works, and we'll finish the tutorial clip there.